Good morning. In this video, we're going to be discussing slopes and linear equations, but first, a couple of topics that we'll need to know in the near future. One is that we need to know how to plot points. This should be a review for us, but anytime you see what's called an ordered pair, you should remember that the first number is representing the value of x, and the second number is representing the value of y. And using a graph with two axes here, the x and the y axis, we can find this location on this graph. And we do that by finding the first number on the x-axis. So 1, 2, 3, 4. I'm just making a small dot there. And then the second number on the y-axis, which is a -2. So I go down. And I'd be looking for where those intersect. Now, a lot of the time, we just kind of count over 1, 2, 3, 4. And then since it says y is -2, we would just go down 2. And that's our spot. So that is point A. If we apply that to these other problems, B is -2. So here's the x-axis. We go -2, 1, 2, and then down 7 because it's negative. 1, 2, 3, 4, 5, 6, 7. That is point B. Point C is a +6, then a 1. So 1, 2, 3, 4, 5, 6, and then a 1. And then on point D, it's 0, 8. So remember, x-axis, the 0 is actually right here. So we don't move left or right, and then we go up 8. And so that is point D. Plotting a point. So anytime you see a plotted point, that is a representation of two variable values, the x and the y. And we will use that then when we graph lines to show the solutions for that line. Speaking of linear equations, these are a couple of linear equations that need to be rearranged, and we're going to solve them, but it's going to look different than some of the solving we've done previously. The steps are the same, the simplifications are a little different, and the results are a little different. One thing you'll notice is that they have two variables. We have an x and a y. So when I go to solve an equation, I'm looking to get a variable by itself. And in this case, since there's two different variables, I would need specification as to which variable I'm supposed to get by itself. And so right here, they do tell me that they want me to get x by itself. So the first thing I do then is I identify my variable term, and that there is 3x. And if I want my variable term by itself, then I would need to get rid of this -4y. Now, how do we eliminate a term? That part doesn't change, but it's a little different because this time it has a variable. We would add 4y. That gets rid of the 4y on the -4y on the left side. But I have to add 4y to the other side too. If we read it like a book, we will now have 3x. Then these would cancel, which was my goal. This part's a little different. I can't actually combine 12 and 4y because this term has a variable and this term is a constant. They're unlike terms and therefore they don't go together. So what you do is you just simply write those two terms down. However, it's more formal to write what we'll call the more important term first. And in math, anything with a variable is a little more important than just a constant. So I would write 4y. My reader knows that it's positive because it doesn't say negative. This 12 is positive, and when I write it down, I will need to put the plus there to separate those two terms. I'm going to rewrite it, but we are not finished because we need to get x entirely by itself. And the way we're going to do that is divide by 3. That part is very normal. On the other side, though, I have two terms, and it's kind of like distribution. We need to do this division to each term and then simplify where we can. So we read it like a book, and now we have x equals, then you get the fraction 4/3 with the variable y. and then 12 over 3 is 4. And this is the answer. Now, it doesn't tell me exactly the value of x because there's a variable over here, and x is dependent upon the value of what y is. If y was 3, then I would plug it in and I'd get 3 divided by 3 is 1, times 4 is 4, plus 4 is 8. So the ordered pair, well, it's in the wrong order. But when I plug in a 3 for y, I get 8 for x. And so x is going to change as we change the value of y. Let's look at this one. Same idea. This time we're solving for the variable c. So find your variable term, isolate that term by getting rid of the other term here, the 2b, which is positive. So I'm going to subtract 2b. When I subtract 2b from the left side, I must do it to the right side. Read it like a book. Those will cancel. Leave me with 5c equals, and then I have these two terms that do not go together. I'm going to put the variable term first because it's more important, and then the minus 10. I'm going to rewrite it. And then I'm going to get c by itself by dividing by 5. And again, we must do that to each term. Read it like a book, and you will have c equals your fraction negative 2/5 b, and then negative 10 over positive 5 is negative 2. So that is a skill we will need in the near future, not so much for today, but there you have seen it. Here's some terms. Here are some terms and vocabulary I want us to be familiar with. You should know some of this. This is a point, and if I were to name that point using the graph to read it, it looks like it's at a 9 on the x, and it looks like it's a negative 5 on the y. So this would be the ordered pair 9, negative 5 if you wanted to specifically name that point. This is the x-axis. This is the y-axis. The origin is the ordered pair 0, 0. That's where we start anything. And then this is a line. We'll talk more about those in just a bit. The slope of the line is the steepness of a line. And I'm sure that's not the first time you've heard that word, slope. A line never gets more steep or less steep. So it doesn't really matter at what part of the line you look at, you'll always find the correct slope as long as you do it appropriately. How do we find that steepness? Well, mathematically, you're going to take the vertical change and divide it by the horizontal change, which can be notated as delta y over delta x. That's really not that important, but when you go to buy something at the store, the money that the cashier gives you back is called your change. And we find that value by subtracting the cost of what you were buying by the amount of money that you gave. And so we do the same thing here. To find the vertical change, you would take the y values of your two ordered pairs and you subtract them. That gives you the vertical change. To find the horizontal change, you take the x values and subtract them, and that gives you the horizontal change. And this is the slope formula. Some of you may have seen that before, used that before. It's like a recipe. It's a recipe for finding the slope. And so, like a recipe, some of you may have it memorized, others of you may need to read it from the recipe book, but that's how you do it. We can also find the slope from counting if we use a graph, or a graph is provided for us, and this formula will do the same thing. So let's try it by counting first, and I'm sure this has been done before. Here's one of those points. There's actually one here. There's another one here. I'm just going to use the two that were labeled, and we're going to find what is called, and know this is a familiar phrasing, rise over run. And so we're going to calculate our rise by counting up or down from one point to the height of the other point. So since we're at this point and I'm trying to get to the same height as that point, I would just go up. It looks like 2 units. And then I would do my run from that to 1, 2, 3, 4, 5, 6 to here. That was a 6. And so my slope is 2 over 6, which can be rewritten as a reduced fraction of 1 over 3. The last thing we want to check is make sure that your slope number, the steepness number, is matching this idea of positive or negative slopes. As we read it like a book, this goes from left to right and it goes up. That makes this have to be a positive number. Like looking at the next example, since this one's going down from left to right, this has to be a negative answer. So if you wanted to, you can go ahead and know that this fraction will be negative. Let's go ahead and find our rise and our run and see exactly what that slope is. So it looks like this point has been identified for me, and this one. Sometimes you will have to find your own points, and that's okay. It's not hard to do. So since I'm starting here, I'm trying to match the height of this one. So how much is the change? 1, 2, 3, 4 units is my rise. Even though I went down, we still call it rise. And then my run is 1, 2, 3, 4, 5, 6. Okay. And the fact that we went down, that's actually what made this negative. We knew it was going to be negative. I've already written my negative there. And 4 over 6 becomes 2/3. This has a negative 2/3 slope. So we found both of those. This one's positive, this one's negative. Now over here, it's going to be a little more difficult for me to identify whether something's positive or negative. So I'm going to have to be really careful with my signs when I use my slope formula. Just follow the recipe as perfectly as you can. M represents my slope, and I don't know what that is. It's what I'm here to find out. These are my x and y values. X and y values. And it really doesn't matter. A lot of students have asked, which one goes here, which one goes here. It doesn't matter which y value goes there, but what does matter is consistency. So I'm going to pick, because it's the first one, I'm just going to pick the 7 to be this y value. So I'm going to write 7. After we've done the y, there's a minus sign right there. That's what goes next. And now I look for the other y value. Since I already used 7, -3 is the other y value. Now is where it's important to be consistent. Since I used the 7 as my first number here, I must use the 2 as my first number here, because that ordered pair goes together. So we have 2 and then the minus sign and then the other x value, which is -3. Now we need to calculate. In the numerator, we have this double negative. So it's really saying take away a -3, and that's going to actually give 3. If you take away a -3, you're giving a 3, adding a 3. The same thing down here, that can be rewritten as 2 plus 3. And now when we make this calculation, you get 10 over 5. Now, anytime in math we have the opportunity to write something more simply, we do it. And so 10 over 5 can simply be written as 2. This fraction over here does tell me my rise and my run. This is my rise and my run. This one doesn't have a denominator that's written. So if it comes to the point where you need a rise and a run and you only have an integer here, you will need to remember that your denominator is a 1 and use it as such. Okay, we're going to do the slope formula one more time on this point here, or these set of points here. My slope can be found by doing the y value. So remember, the y value is always the second number. I don't care which one you use. I'm going to use the 5. Then it says do minus. Then it says do the other y value. Then we're going to do the x's. Since I started with the 5, I'm going to start my x's with this. Then do the minus. Then do the other x value. In this case, both x values were the same, so the order really wouldn't have mattered, but keep in mind, otherwise you need to be consistent with that. Let's make our calculations. We're going to get 5 plus 1. I'm going to write that down first. 5 plus 1, which does give me a 6. And down here we get a negative 4. That will stay. And then these two, this double negative will become a plus, and then we have a 4. And so we get a 5 plus 1 is 6. A negative 4 plus 4 is a 0. Okay? And think of rise over run. It says that I'm rising 6. Right? Well, that was not very good. I am rising 6, or the line is. And then it's running 0. So it's not moving left or right. And then it would rise again. And you're going to end up with a vertical line. That actually has a slope that is called undefined. And that's because we can't divide by 0. We don't know what that value is. 0 divided by 6, that is a value we know. That's 0. But 6 divided by 0 is undefined. And undefined slopes will lead us to a vertical line, as we see here. So, speaking of those type of slopes, what types of slopes are they? We have positive slope, which we've talked about. We have a negative slope, which we've talked about. This is a 0 slope, and you can think of that because your rise would be 0. Your run would exist in some fashion. So if you have 0 over a number, that calculates to be 0. That's why we call that a 0 slope. In an undefined slope, you do have a rise, but your run is non-existent. And that's why we come up with a can't divide by 0 situation, and we get an undefined slope. So let's take this and apply it to something called slope-intercept form. Y equals mx plus b, where m is your slope and b is what we call the y-intercept. The y-intercept is defined here as the point where the line crosses the y-axis, and it is represented by the letter b. I don't know why it's represented by the letter b, but it is. And it's the y-intercept, not an x-intercept, which is a different thing. But for slope-intercept form, it is the y-intercept. So in order to fill this equation out, it says to write this equation of this line, we will need to know what my slope is, and we will need to know what my y-intercept is. So remember, slope is your rise over run. Here looks like what I call a pretty point. Here looks like another pretty point. And I'm just going to count my rise. So I'm going to go down on this one. 1, 2. My rise is 2. And then I'm going to go with my run. 1, 2, 3, 4, 5, 6. And look at the line and make sure that you have the correct sign. Is it positive, negative? Is it 0 or undefined? Since it's going downhill from left to right, this needs to be negative. And then I will reduce that. So m is negative 1/3. The y-intercept is actually really easy to identify. Just trace your line and then find where it hits. This is the y-axis. Find where you hit that, and that number is your answer. The b value here, it's kind of covered up. but that is a 4. So b is 4, m is negative 1/3. Once we know those two values, I can write my equation by following this recipe. Y equals, then it says to write the number m. Well, we know that m is negative 1/3. After m, it says to put x. Then after that, we would add the term, which is my y-intercept, the b value of 4. This was a positive 4, so I put plus 4. If it was a negative number, I would put minus and then that number. This is the equation of this line. And all the points on that line are solutions to this equation. So the ordered pair 6, 2 would satisfy this equation. If I plug in a 6 right here, it would compute to give me a 2 right here. And that's a good thing to learn about graphs, is that it tells you a lot of information. You can interpret these points as solutions to this equation. So let's just run through a couple examples where we are finding the equation of the line in the form y equals mx plus b. So here they told me slope is 2. Remember, m is slope, so m is 2. This is a notation for y-intercept. It's telling me the actual ordered pair. But if I were to plot that line, or plot that point on this graph, 0, 3, that would be 0 and then up 3. So what is the y-intercept? The y-intercept is simply the y value if x is 0. That's the only time that the y-intercept would be the y value, is if the x value is 0. So my b value is just 3. And once I have those two numbers, I'm just following this recipe, and I get y equals 2x plus 3. Looking at the next example, this time they actually told me the slope as the letter m, and they told me the y-intercept as the letter b. So I just need to write my equation. Y equals, put the m value. After the m value, put x. After the x, we put the last term, which is my y-intercept, plus 2.6. And as you look at this equation, I want you to get an idea of what this line looks like. It's going to hit the y-axis about, if that's 3, it's going to hit about right here, 2.6. And then it's going to be a negative slope. So I know it's going, this direction in some fashion. We can talk more about that. The more you do it, the more you'll be able to visualize that. Okay, this time they gave me the slope. Remember, slope is the letter m, so that's negative 1. And again, they gave me the y-intercept as an ordered pair. That means my b value would just be 2. My equation, y equals negative 1x and then a positive 2. And the only thing that I would change about my answer is we don't need the 1 in this equation. If you saw this written in a textbook, it would just say y equals negative x plus 2. And that would be the preferred way to write that. On this last example, notice they didn't tell me my slope. They gave me the x-intercept, which is different than my y-intercept, and they gave me two ordered pairs to do that. So we need the slope. What is the slope? I don't know. What's my y-intercept? We can identify that from right here. That's negative 5. But we need the slope. So I need to use the information provided to find the slope. And so I go back to my slope formula and we plug it in. Give me a y value. I'll just start here. That's 0. Then it says minus. Give me the other y value. Well, that's negative 5. Give me the x value that went with your first y value. So this was the first y value, means we have to do negative 2 right here, minus the other x value, which was a 0. We will calculate this. 0, remember that's 0, now it's a plus 5. And then a negative 2 minus nothing. Well, that's going to leave us with negative 2. And we get a 5 over negative 2. So my slope, which was a question mark, is now negative 5 halves. And we do like our slope to be written as a fraction for the sake of having the rise value and the run value easily identifiable. Okay, now that we know m and we know b, we write the equation, and it looks like this. Y equals negative 5 halves, then x, and since it's a negative y-intercept, I put minus, and I put 5. Again, let's think about what this looks like. On a graph, we know that here's the y-axis. It's going to hit at negative 5. So here are your positive numbers. Down here are your negative numbers. Negative 5 might be around in there. It's a negative slope, and it's actually pretty steep. It's a 2.5 steepness. And so it looks something like that. All right, on this one, we are given the slope, which I would represent as m, and we're given a point that this line is supposed to pass through, which those two coordinates represent x and y. What we're going to do is we're going to figure out then, we need to know what is my y-intercept. So if I use y equals mx plus b as my kind of outline here, I know the y value can be listed as 5 because of the y being 5 right here. And I know the slope is negative 3/4 because that's what they gave me. And I know that the x value can be used, can be negative 2. So if I go to solve this, I will then be able to find out what my y-intercept is. So we simplify this negative 3/4 times negative 2, which if you multiply the numerators here, you're going to get a positive 6 over a 4, which reduces to be 3 halves. Now, imagine that it just said this, 3 plus b. How would I get b by itself? I would subtract 3 from both sides, but it actually says 3 halves. You just do the same thing. You're going to subtract 3 halves from both sides. And now this calculation is a little tricky. I'm going to go over here and do it. We're going to do 5 minus 3 halves. Once I do that, that's my b value. And it's only tricky because of the fraction. And I need common denominators. So the denominator here is a 2 and the denominator here is a 1. I can easily change this 1 to a 2. Let me actually do that. And then change the 5 in the same way. So like 1 became a 2 because I multiplied by 2. Let's just change the 5 in the same way. 5 times 2 is 10. So now we have 10 halves minus 3 halves. And if you do 10 minus 3, you will find that that is 7 halves. And that is my b value. So b equals 7 halves. And so this big question mark is no longer a question mark. Now that I have the two things that I need, my slope and my y-intercept, I can write my equation. Negative 3/4 x plus 7 halves. That is the line that has that slope, as you see here, and it will pass through those two coordinates. Let's try this again, but the situation's a little more difficult because it gives us just 2 points. They don't tell me the slope. They don't tell me the y-intercept. And so first, we're going to find the slope. So on the last one, they gave me the slope. On this one, I'm required to find it. And anytime you are given 2 points for a line, you can find the slope using the slope formula, which looks like this. I'm going to go ahead and fill that out. So remember, it's always xy, 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 xy. And we're going to put a y value right here. So this y value is what I'll use first. It's a 1. Then we do minus. Then we do the other y value, which is a 4. Keep it consistent with my colors here. And then we'll do the x value. Well, since I started with the 1 right here, now I got to do this x value, which was also a 1. And then minus the other x value, which is a negative 5. So if we make this calculation, 1 minus 4 is negative 3. 1 plus 5 is 6. So what is my slope? If I reduce this, we get negative 1/2. So now I know my slope is negative 1/2, but I'm still missing my y-intercept. Now that we know the slope, though, and a point, or at least 1 point, I'm going to use my y equals mx plus b. I'm going to do this process again, but now for this problem. So I write y equals mx plus b, and I'll use this point right here. So my y value is 1, my m is negative 1/2, my x is 1, and then I don't know what b is yet. So let's simplify. We're going to get 1 equals 1 times negative 1/2. Well, anything times 1 is itself. And so we have a negative 1/2. How would I get b by itself? Since it says negative 1/2, I'm just going to add 1/2. Since we're adding, this might be a little easier to understand. It's 1 plus 1/2. Well, that is 1 and 1/2 as a mixed number. But as an improper fraction, which is how we would prefer this, 2 times 1 is 2, plus 1 is 3. You should get 3/2. So what is my b value? My y-intercept, it's 3/2. That means my equation must be y equals negative 1/2 x plus 3/2. And so that is the answer to this question. Okay, let's look at a couple special situations, some other examples that can help you out. Find the equation of line with a 0 slope. Okay, let's think about that. Looking at our notes, is this a 0 slope? No, that's positive. This is a negative slope. This or this, which one is a 0 slope? Well, hopefully you remember that this one is undefined. It's this one that's the 0 slope. That's a horizontal line. So if I had a graph and the point 8, negative 3 is like right here, and I was drawing a horizontal line through that point, what you're going to realize is that all of these ordered pairs have something in common. Like this ordered pair here would be 11, negative 3. And this one would be 0, negative 3. And of course, this one is the 8, negative 3. What do you notice? You'll notice that the y value is always the same number. The y value is negative 3. Every horizontal line has the same y value the whole time. It never goes up or down. So its y value would always stay the same. And so a horizontal line is just going to be y equals negative 3. So once again, we have an equation with 0 slope, and it's passing through this point. You can draw a quick graph. Negative 4, 5. Negative 4, 5 is right there. Horizontal, because it's a 0 slope. And so it's going to be y equals, and the same y value that's here is the same y value that's here or here, and that number is 5. So y equals 5. Find the equation of the line with a 0 slope that passes through some point called AB. Okay, well, from the two examples that we just did, we realize that a zero slope will be y equals, and then whatever the y value is of the point that it's passing through. So this one would be y equals, and then whatever the y value is here. So we would call that b. Now we have a challenge question. It says, find the equation of a line that's undefined slope. Well, we established that an undefined slope means that it is a vertical line. And we're passing through some point A, B. Well, let's look at a picture here. If we have a vertical line, I don't know whatever these points are, but let's say that this one is A, B, then this one would be A, comma, not B, but something else. And this one would be A, comma, something different than that. But notice the first coordinate, the x value will always be A. And so anytime you have a vertical line, it's always going to be x equals whatever value is the x value. So hopefully that helps you on those special situations. Your horizontal and vertical line equations can be quicker and easier if you understand what they're actually saying. If you have any questions, let me know.